In 1892, a paleontologist named Joseph Frederick Whiteaves cracked open a slab of rock in the Canadian Rockies and found something he couldn't explain. It looked like the abdomen of a shrimp, segmented, curled, about 76 millimeters long, but it didn't match any shrimp he'd ever seen. So he gave it a name that, looking back, might be the most accidentally perfect name in the history of science. He called it Anomalocaris canadensis, the weird shrimp from Canada. 19 years later, another paleontologist, the legendary Charles Doolittle Walcott, was working at the Burgess Shale in British Columbia, one of the richest fossil sites on Earth. He found a circular, disc-shaped fossil with plates arranged in a radial pattern, like a sliced pineapple. Clearly, he thought, this was an ancient jellyfish. He named it Padia. That same year, Walcott found a third fossil, a large, flat body with lobes running down both sides. He classified it as a sea cucumber and called it Lagania, a weird shrimp, a jellyfish, a sea cucumber. 3 separate creatures from 3 separate discoveries. And for nearly a century, that's where the story stayed. Nobody questioned it, nobody connected them. And all the while, sitting in museum drawers across the world, the pieces of the most terrifying predator the Cambrian Ocean had ever produced were waiting, in plain sight, to be assembled. But I'm getting ahead of myself. Before we can understand what these scientists missed, we need to understand the world this creature lived in. And to do that, you need to travel back roughly 515 million years. Picture this. You're standing waist-deep in warm, shallow water, about 22 degrees Celsius, like a tropical hotel pool. Sunlight pours through the surface all the way to the bottom. Beneath your feet, the seafloor is coated in a slick, spongy mat of bacteria. You can feel it squish between your toes. The air above the surface is thin and strange. There are no trees on land, no grass, no insects. The continents are barren slabs of rock. Every complex living thing on Earth is in this water with you, and most of it is tiny, unbelievably tiny. The average marine arthropod during the Cambrian measured a few millimeters to a couple of centimeters. Many were barely visible to the naked eye. The largest creatures you'd notice are trilobites, scuttling across the mud like armored pill bugs, maybe the size of your thumb. This is a world of miniatures, a world of things that crawl, drift, and filter, but somewhere at the edge of your vision, something moves differently. It doesn't crawl, it doesn't drift, it glides, flat, silent, and fast, like a shadow cutting through the water column without creating a ripple. And it's heading straight towards something behind you. You are looking at the first apex predator in the history of planet Earth. At a total length of roughly 50 centimeters, about 20 inches, the length of your forearm from elbow to fingertip, and weighing an estimated 2 kilograms, or about 4 pounds, Anomalocaris was not, by modern standards, large. It was roughly the size of a large lobster, but in that Cambrian Ocean, it was a nightmare of proportion. It was bigger than 99% of every panarthropod species alive at the time. To put that in perspective, imagine a world where every living thing in your city is the size of a coin. And then imagine a wolf walking down Main Street. That was Anomalocaris. Now here's what makes this animal's story so strange. For over 100 years, we had its body parts in our hands. And we had absolutely no idea what we were holding. Remember Whiteaves' weird shrimp? That was a grasping appendage, one of 2 segmented spine-lined arms that extended up to 18 centimeters from the creature's head. Remember Walcott's jellyfish? That was the mouth. A ring of 32 interlocking plates arranged in a triradial pattern that clamped down from 3 angles simultaneously. And Walcott's sea cucumber? That was the body. A flattened, flexible form lined with 14 pairs of overlapping swimming flaps. 3 creatures, 3 discoveries, 1 animal, and nobody knew. The reason for this century-long deception lies in the animal's construction. Unlike trilobites, which were wrapped in hard, mineralized exoskeletons that fossilize beautifully, Anomalocaris was almost entirely soft. Flexible cuticle, muscle, cartilage. When it died and sank, its body fell apart. The hard appendages ended up in one rock layer. The calcified mouth plates ended up in another. The soft body decomposed into a flat impression somewhere else entirely. Each piece looked like a completely different organism, and the scientists who found them, some of the most brilliant minds of their generation, were systematically fooled by the fossil record itself. For nearly 70 years, 3 separate species sat in museum collections across the world. In 1928, Henriksen looked at an appendage and thought it was part of a crustacean shell. In 1978, Simon Conway Morris examined the body fossil with the mouth impression on top of it and concluded it was a jellyfish squashed on top of a sponge. Nobody suspected the truth. And then, in the early 1980s, it all came crashing together. Harry B. Whittington and Derek Briggs at Cambridge University were re-examining Burgess Shale specimens when they acquired a large, new new fossil. Whittington began clearing it with micro-needles, painstakingly chipping away rock grain by grain, and as the stone fell away, his face went pale. Attached to the head of the sea cucumber were 2 of Whiteaves' champmouth shrimp appendages, and nestled in its throat was Walcott's jellyfish. 3 creatures became one, and in that moment, the Cambrian Ocean gained its king. But now a new question emerged, one that would take another 4 decades to answer. What exactly could this king do? Let's start with how it moved. Anomalocaris didn't paddle or thrash through the water. The 14 pairs of lateral flaps along its body rippled in smooth, undulating waves, almost exactly the way a modern stingray swims. Computational fluid dynamics simulations confirmed that this motion was intrinsically stable, meaning the animal didn't need to waste a single neuron keeping itself balanced. Every ounce of brain power went to one thing: finding and killing prey. At an optimal cruising speed of 3 body lengths per second, a full-grown individual could hit 1.5 meters per second, about 5.4 kilometers per hour. I know that doesn't sound fast, but in an ocean where most things either sat still or drifted with the current, 1.5 meters per second was a death sentence with no parole. And then there was the tail, a massive V-shaped fan made of 3 pairs of vanes that, when angled past 25 degrees against the current, generated a sudden burst of both lift and thrust. In other words, Anomalocaris could execute sharp, tight turns at full speed. It wasn't just fast in a straight line. It could chase you around corners. Talk about nowhere to hide. But speed and agility are only half the equation. A pursuit predator is useless without the ability to find its target. And this is where the story gets truly, genuinely insane. In 2011, paleontologist John Patterson and his team were working at the Emu Bay Shale on Kangaroo Island, South Australia. Among 5,000 specimens, they found just 2 that stopped them cold. A pair of fossilized compound eyes, pear-shaped, 2 to 3 centimeters long, preserved in extraordinary detail through iron oxide and calcium phosphate mineralization. The eyes could only have belonged to Anomalocaris, and when Patterson put them under a microscope and 3D scanner, what he saw defied everything scientists thought they knew about early animal vision. Each eye contained at least 16,000 hexagonally packed lenses. 16,000 in a single eye. Let that number sit for a moment, 500 million years ago. Before any animal on Earth had developed a hardened skeleton, before jaws existed, before fins, before legs, before lungs, there were eyes with 16,000 lenses mounted on muscular stalks, sweeping a near 360-degree field of vision across a sunlit ocean. The common housefly today has 3,200. Most ants have fewer than 1,000. The only modern animal that comes close is the predatory dragonfly, which reaches about 28,000 lenses. And dragonflies have had 300 million additional years of evolution to get there. Anomalocaris achieved comparable visual sophistication when the most advanced eyes on any other living thing, the trilobite, had a few thousand blurry lenses. Its vision was roughly 30 times sharper than its best-eyed prey, and Patterson estimated that the preserved count of 16,000 was conservative. If the entire spherical surface of the eye had been covered, and there's reason to believe it was, the real number may have been 24,000 to 30,000 lenses per eye. There's even evidence suggesting dichromatic color vision, meaning this animal could distinguish colors in its blue-green world. Ironically, it was these very eyes that may have reshaped all of evolution. When a predator can see you from across the reef while you're hiding motionless in the mud, your survival options become brutally simple. Grow a shell, sprout spines, or learn to burrow. Scientists believe the presence of Anomalocaris, a free-swimming, visually acute killer, was one of the key triggers of the Cambrian evolutionary arms race, the cascade of defensive adaptations that gave rise to shells, armor, and complex body plans across the animal kingdom. Now, remember that old image of Anomalocaris? The one where it swoops down to the ocean floor, grabs an armored trilobite in its grasping appendages, and grinds it apart with that pineapple ring mouth? For decades, that was the picture. Paleontologists pointed to W-shaped bite marks on trilobite fossils as proof. It was in every textbook, every documentary. And in July 2023, a team of researchers blew it apart. Dr. Russell Bicknell from the American Museum of Natural History and Dr. Imran Rahman from the Natural History Museum in London built a full 3D digital model of the grasping appendages, then ran finite element analysis and computational fluid dynamics simulations to test what would actually happen if Anomalocaris tried to crush a trilobite's exoskeleton. The answer was devastating. For the predator, the appendages would snap, the mouth plates would crack, the entire weapon system would be destroyed by the recoil of attacking something that hard. And the fossil record confirmed it. Out of thousands of recovered appendage fossils, only a single specimen showed any damage whatsoever. Anomalocaris never touched those trilobites. It couldn't. It was soft and squishy, attacking something made of biological rock. The real shell crackers were bottom-dwelling predators like Hirdia, Cambrorastor, and Sydneia, animals with harder mouths built for plowing through the seafloor. So what was Anomalocaris actually hunting with those 16,000 lens eyes and those barbed grasping arms? Soft-bodied prey, jellyfish, marine worms, large zooplankton, possibly even early chordates, the soft, swimming ancestors of every vertebrate alive today, including you. It didn't crush, it impaled, it intercepted. It was not a tank, it was a fighter jet. And for tens of millions of years, nothing in the ocean could touch it. The Radiodonta, the order to which Anomalocaris belonged, had spread across the planet. Fossils have been found in Canada, Australia, China, and the United States. Anomalocaris itself was the most cosmopolitan genus of the entire order, the only one confirmed on virtually every major landmass of the Cambrian world. They survived through at least 3 distinct evolutionary phases. They outlasted countless lesser lineages. Recent excavations from the Xinjiang Lagerstätte in China, a site that preserves soft tissue even better than the Burgess Shale, continue to reveal new radiodont species, and a 2025 study describing Masura fentoni from the Burgess Shale itself confirmed that the diversity of radiodont predators was even greater than anyone assumed. By every measure of ecological dominance, the Radiodonta were built to last. And then the Ordovician arrived, and everything changed. The oceans filled with new competitors, giant nautiloid cephalopods, cone-shelled predators with grasping tentacles, massive eurypterids, sea scorpions the size of crocodiles, the first jawed fish. The open-water hunting niche that Anomalocaris had owned unchallenged was suddenly crowded with bigger, meaner, better armored rivals. Interestingly enough, some of Anomalocaris' closest descendants responded to this pressure in the most unexpected way imaginable. They stopped fighting. The 2-meter-long Edgyrocassus ben Moulai, discovered in Ordovician rocks from Morocco, had transformed its ancestors' barbed killing claws into enormous filter-feeding combs, rows of fine bristles that strained plankton from the water. the most ferocious lineage of the Cambrian, had become a gentle giant, drifting through the open ocean with its mouth open, essentially becoming the first baleen whale of the Paleozoic. Hundreds of millions of years before actual whales existed. From apex killer to peaceful filter feeder, from grasping spines to feathered combs. If that isn't one of the most extraordinary pivots in the history of evolution, I don't know what is. Unfortunately, even this radical reinvention couldn't save them. Climate shifts through the Silurian and Devonian, relentless competition from cephalopods and jawed vertebrates, and cascading ecosystem collapses eventually swept the last of the radiodonta from the fossil record. Sadly, not even 500 million years of evolutionary versatility was enough. The weird shrimp closed its 16,000 lens eyes for the final time. But here's the thing. You are living in a world that Anomalocaris built. Every hard shell on every crab on every beach. Every compound eye on every dragonfly hunting above every pond. Every burrowing worm hiding beneath every tide pool. All of it exists in part because 500 million years ago, a soft-bodied predator with impossible eyes forced every other living thing in the ocean to either adapt or die. It didn't just hunt, it sculpted. It was the invisible architect of the Cambrian arms race, and the echoes of its reign are coded into the biology of nearly every animal alive today. Not bad for a weird shrimp from Canada. And if this kind of deep dive into Earth's most ancient killers is your thing, consider subscribing. There's a lot more where this came from.